Hi, hello. Today we'll talk about top k frequent words. So given an array of strings, words, and an integer k, so we have two input, they were expecting we will return k most frequent strings. That answer should be sorted by the frequency from highest to lowest. When you'll find some word whose frequency are same, like some word was being repeated twice, and other word is also repeated twice. In that case, answer should be lexicographical order. So let's say in the example first, I love Leetcode, I love coding. Case 2. Answer is I love. So I and love are two most frequent words. I comes before love due to a lower alphabetical order. Now let's understand with an example further. Alright, we take an example. Suppose we say C, 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 D 2 times, A 4 times, and suppose B 2 times. In this case, as per the example, they were expecting A is repeated 4 times, and C repeated 3 times, D 2 times, and B 2 times as per the answer sorting. First, they were expecting from highest to lowest, that is the requirement. Second, their count of any word, like here B and D count is similar. In that case, they should be lexicographical order. So B will come first and D will come after that. So the answer A, C, B, D. A comes first because of its more count. C comes after, and out of these B and D and B, they have the same count here, 2 and 2. So but B will come as per its lexicographical ordering, and D will come after that. Now let's see that how this question map with our template and which coding pattern we have to use for this. First thing, you can see there is some collection of some words. So collection is there. That's the first thing we observe. Second, they were asking k most frequent words. So that's the second requirement. And third, for sure, the ordering of the answer. But we know when there is some collection is given and k box element is expected, these two things come up, we will use top k element coding pattern. So in that case, we will use top k element coding pattern. And in this empty place, what I'm saying, it could be most, it could be frequent, it could be largest, or like any parameter that could be given. So we come to know we have to solve this question by top k element coding pattern. Wise, what was top k element coding pattern? Top k element. We already discussed about that there are 3 steps. The first, we have to decide either we have to use a min heap or we have to use a max heap. If smallest or some less such thing is expected, we will use max heap. If largest, maximum, frequent is such thing is expected, we will use min heap. Why we will use max heap, why we'll use min heap, I discussed this thing already. It is about 2 point, maybe I never explained this thing very clearly, that there is a concept of surface and sinking. Surfacing and sinking. So what is surface and sinking? It means that when, let's understand this thing, that part with an example. If, let's put there some numbers. In these numbers, we have to return 3 largest number, right? three largest numbers are expected. So what we will do first, we'll say use, just think about like a water. It's a bottle, it's some basket of water. Here is some, let's suppose there is a water. Now whatever number comes, what will sync, that is the biggest, and the one which will go to the service will be of the which is coming with the minimum requirement. Let's suppose we say 3. So here the requirement comes. So it says that 3 numbers only expected, 3 largest number. So first 3 will come, it will say okay, 3 will come here, it will remain on the surface, then 2 come. So 2 will say okay, 3 says now I am heavy, I will sink, and 2 will remain, 2 will get to the surface. So 2 will come here, 3 will sink. Now 4 comes, it says you remain there, 2, and I'm going to sink because I am largest. So those elements that satisfy our requirement, they sink, and those which are satisfying our requirement with minimum, they go to the surface, like this 2. Out of these 3 elements, 2 is the one which is fulfilling, which is the smallest. Now if 1 come, in that case it will be ignored because that is already not satisfying our surface condition, so it will go away. So 1 will not come. So then 5 comes up, and 5 says okay, this is my position, so that will be gone, and we'll say oh, there are some elements which were already being synced, and it will rebalance the tree, and then the number which satisfy less, it will go to the surface, and 5 will sink. So that is surface and sink. That's why I was talking about use either max heap or min heap in a reverse way. On the second part, what we look for the bases. We look for the base, we look for the ground, what the question is asking. In this question, as you can see, there are 2 things which was being asked. The first, they were saying highest to lowest, that should be the order of our answer. And second, they are saying if their count is equal, so count get equal, so lexicographical order should be given, right? So that would be our basis for our priority queue to get them sorted. And the third part we already talked about. We will iterate all elements, and in our min or max heap we will only keep k elements, and then we will return them, right? In this question there is also a little trick. What will happen, that's why I'm discussing all that syncing and surfacing. Now what happened in this case, if you will go through all the iteration, you will see that those numbers like A will be synced because its count is maximum. C will be synced also, and now which will be on the surface? D will come on the surface if 4 elements were expected, and B will go down, right? That will be the look if 4 elements were expected. If 3 elements will be expected, B would be on the surface, and A and C would be synced, right? They will be synced, and that will be on surface. Why I was talking about this thing? Because the answer which was expected is A, C, B, and D. But if we will dequeue that in case of 4 numbers were expected when they were asking about 4 numbers in our example, then that will be the answer. So I'm saying our all elements in order are synced, so we have to dequeue them all, and then we have to get the answer. So that's why I'm discussing, because when we will go into the code we will use that, right? So here this is all. Let's go to the code and see how we can implement our template. All right, now let's see how we can implement our template. We will follow the same step. The first step, we will decide either you have to use min or max heap. We will look into the ground on which we have to make the ordering in our priority queue, ground or basis. And in the third step, we will iterate and keep only k element and return. Now, maybe in some previous question I talk about this part in my second step, and in the third step I actually mentioned that we will return the answer. So let's add this second step as per your in this question, so like it's an extended version. Okay, so we will say iterate and keep only k elements, and then in the fourth step we will return the answer. So what we are looking, so first we will say that we have to use min heap because they were expecting k most frequent elements, so k min heap, and that will be a priority queue. That priority queue should be of some word count. We would make a class, let's suppose some word count, and that class will keep word as a string and count as an int. So we will discuss about ordering, what it will be, but that will be our case class. That will be a word count. We can solve this question without even introducing this class using a tuple, but for the readability I'm introducing this class. So we'll use a word, that will be a string, and we'll say count, which will be an int. Now in this priority queue we have to decide about the ordering. In the question they already ask about that the answer should be from highest to lowest, and it should be, if the count get equal, we want lexicographical order of the string. Now we will use the same what was expected, so we will say ordering dot from less than, and we would say word count of 1 and word count of 2. So in that case we will expect that, okay, if word count 1 dot count is less than our second word count, second words count, so we will say false. Else if word count 1 dot count get equal to the word count second count, and the word, in that case we will consider the lexicographical order. We will say word that should be equal to second word, it should be greater than that. Okay, so we will say false. In the else part we will say true. So that will be our ordering. This is what we were talking about for the ground or basis. What was expected, we wrote the same. Now in the third part, what we'll do, we'll make the map. We will make the mapping, the count of the word. We will say words dot group by our identity. So means that 2 is 2, 3 and 3, so it will group them, group all those words, and then we will say view dot map values, and we will say with the size. And in that case answer will be something like C will be saying, as per our example what we were talking about, CC DD AAA and BB. In that case C will be 3, D would be 2, A will be 4, and B would be 2. So we group them and make the mapping. Now in the last step we will say we will iterate. We were here on the third step, we say map dot for each. I'd rather make a case and we say it should be word, that should be count, because this is word and that is its count. And then we would follow the same step. Okay, we will say min heap dot nq as a word count, and we will put word here, count here, and then we will say if min heap dot its size get bigger than the required k, we will say min heap dot sorry, we have a dq, and finally, now that here is the point which I was discussing, that all those elements which were capital like C, like CA, C and B would be synced and D will be on surface, so we have to dequeue them all. So we will say min heap dot dequeue all, and then we should say map, and that map will say X, it's a word. Here we have to tell explicitly to the compiler, just ignore the syntax. So we will say word count, and then we say X dot word. So here we only going to get the word, and like in the min heap from the word count we only get the word, and then we'll make the list and we will reverse that, and that's it. So I forgot about adding its import scala dot collection dot mutable, and then if I will run the code, okay, I missed something here. We have a typo here. Run it again, and that's it. Let's put the example what we were discussing. Run it again, and that works fine. Thanks. Well, if we talk about its functional implementation, because Scala is object-oriented and functional programming also, we can write down its functional code quickly, and that will be pretty interesting. Okay, I will not explain anything because I was expecting to make a new course for that, and then we will talk about only FP solution in that case. So just get rid of all that code here, and now if we go with the functional implementation, that would be I will not explain, I will just write down. So we will say words, and we have to say fold left, and we expect that the value, we will initialize the value, that will be map. It is an immutable map, which will be a string, and that will be count. And in that case we will say, in case you never find any value, so we say with default value 0. In that case we would say, okay, we have to close, and now when in the in its implementation we will say we have a map and words come from here. So words, so it's the first word come, then second, then third, and the first initial value of the map will come from here. And now we would say, let's go further, and now in that case we will say map. Every time it will give a new map with that, so we'll say map and that word. So we have to make the map, and in that case we say map get the value of word and plus 1. Here we are actually making the same count with the values, and then we will say to list, and we will sort by all that with the same with the ordering which was expected. We will say that whichever the element it is, because this is a tuple, and we say x dot second, which was the count. So here we are saying by the count make the min, and then you will say x dot by the first, which is the word. So first is actually highest to lowest order, and then we are saying lexicographical order in case they get map, and we say map, and we provide only the word, because in the tuple this is actually a tuple of word and count. And then finally we will say take only k elements, and that's it. That's a simple code for functional code, and it would work. Thanks.